today's lesson, we're going to learn about domain and range. Domain, by definition, is the set of all possible x values, and range, by definition, is the set of all possible y values. So remember that if you want to circle it on your paper, that domain is x, and then the range is going to be our y values. Discontinuous can be represented as isolated points. For discontinuous relations, your domain and range will be a set of individual values. So again, a set of values here, I'll highlight it in orange, has those little brackets that are squiggled here. We go ahead and start with the first one, and I'm going to go ahead and highlight all my x values, which for points are the first values, the ones before the comma. I'm going to list them as a set, so I use that bracket to then write all of them from least to greatest order. Well, -2 comes first, then 0, 1, and 6. I close my set with that bracket. For the range, again, it's going to be the y values. The y values are the second values of my points, the ones after the comma. If you want and did not remember that, you can make a note above these points that the value before the comma is your x and the value after your comma is your y. But we list out again from least to greatest order our range. Well, that's going to be 0, 1, 3, and 4 of the pink numbers I circled there, which are the y values for my range. That is the least to greatest order. For tables, again, they're isolated points. We select the x values that are in the first column, and we go ahead and list them least to greatest in our brackets for set notation. -5, -2, 0, 3, and 6. For the y values of a table, they're going to be in the second column. We go ahead and highlight all of our y values and list them again least to greatest. We have -23. Make sure you always list them least to greatest in your brackets for it to be a set notation properly written. The next one, as you see, they are isolated points on our graph and they are not connected. I'm going to name each point here. So this point here is at -4, 5. I'm naming the x value and the y value of each point. Next point's at -1, up 1. Next point over here is at 2, 4. And last point is at 3, -2. Now that I listed out all my points, I know the values for x, the ones before the comma, are going to be listed in my domain. So list them with a bracket to make it a set. And I go least to greatest, -4, -1, 2, and 3. Notice that I went left to right with those numbers. That's going to be helpful for the next part of this. For the range, it's going to be my y values, the second value of my point after the comma. And again, I'm going least to greatest with my bracket for set notation. -2, 1, 4, then 5. Close it with a bracket. Notice with those numbers, I went from bottom to top. That again is going to be important in our next session when we look at continuous. So this is discontinuous. Sometimes you might hear it as discrete as well. If you want to write that down too, just in case you do ever see the word discrete. Alrighty, now we're going to look at continuous functions. Continuous functions, domain and range, you have to do something differently. When a graph is continuous line, domain is how far the line goes from left to right. That's looking at it horizontally. I'm going to highlight or circle left to right here. Really going to be important. When a graph is a continuous line for range, it's how far the line goes bottom to top. I'm going to highlight the bottom to top here. Again, very important. For continuous relations, your domain and range will be represented as an inequality. Again, highlighting that as well. And then I'm going to keep my same colors like I did before, with domain being the blue and range being my pink. We're actually going to skip these three and kind of break this domain and range for continuous functions down even more on the next problem, next page. So go ahead and make sure you find this setup in your notes and let's go ahead and fill these in. Note that if it is a filled point, we're going to add an equal sign underneath the inequality that is next to the box you are filling in. If it is an open circle, negative infinity or positive infinity, we leave the inequality without an equal sign. Okay, let's go ahead and take a look at filling these in. Like I said, domain is going to be left to right. On the left, I can have a point or arrow, and on the right, I can have a point or arrow. Well, let's go ahead and highlight the furthest thing left here. Hopefully you agree that it is going to be this point over here. That's the furthest thing left. And then I'm going to highlight the furthest thing right and fill in my boxes. So the furthest thing left is this point at -5, -2. But I only want the x value of that point, so I'm going to just fill in -5. Why just the x value? Because it's domain. And I had to put a line underneath because, like I just filled in, if it's a filled point, you have to add the equal sign underneath the inequality. In the box over here, it says fill in with the right point or arrow. Well, the right point is at 7, -4 because it's the domain. I want the x value of that point at 7. It's a filled point, so add a line underneath. For range, we're looking bottom to top. So my bottom point, I'm going to highlight it in pink. It can be, but doesn't have to be the same as your other points. It's the lowest bottomest point on your graph. Here it is at 7, -4. Because it's the range, we select the y value of that point. So that's going to be at -4. Make sure you put an equal sign underneath because it is a filled point. The top point is going to be one that I haven't highlighted before because it is at the top of my graph. That point is at 1, 2, and the y value is what I need for the range of that top point, and we know it's 2. Put a line underneath because it is a filled point. Next one, number 2 here. Again, we want to find the domain and range. I'm going to again go ahead and put in blue the point in left and the point furthest right. I name the x values of the points I just drew. That's going to be -5 on the left, fill in because it is a filled point, and put an equal sign, it's a filled point because the right x value for the point I just bolded and circled there is 1. Range is bottom to top. I'm going to go ahead and bold my bottommost point and my topmost point of the circle. Notice they are different than the left and right points. That's completely fine and pretty usual. We go ahead and fill the range. We have -4. Put a line underneath because that is the y value of my bottom point and it's filled. Then put a line because my top point of a y value of 2 is a filled point as well. Last example, number 3 here. We want to find the domain and range. Again, I'm going to go ahead and circle in blue the left and rightmost points here. The left point, I want to fill in this first box before my inequality sign, and that x value is at -3. If you're struggling with the x values, you can always list the points and then know that the x value comes before my comma. So that's the one I'm filling in because domain is just the x values. And then on the right side, my point is at 4, 2, and I'm going to fill in the x value of that point at 4. Notice that I'm going to leave that one blank because it is an open circle. No equal sign underneath. It comes close but does not touch that point. We go ahead and look at the range. We're going bottom to top with range. The bottom point, I have two options, -3, 0 and 3, 0. But notice that they are both with a y value of 0. So I select the y value, and because it's a filled circle, I put a line underneath. The top point here is going to be at negative 1 comma 4. It's the top point and it's the range I need, so I'm going to use the y value of my top point to fill in that last box here. Put lines underneath again with the 4 because it is included, not an open circle point. Let's go ahead and keep going with some different kind of examples here. We have another note that if your answer after filling the boxes in is negative infinity to infinity, or negative infinity to infinity with y in between. So actually how we read those are negative infinity is less than x is less than infinity, or negative infinity is less than y is less than infinity. Either of those are your answer. You have to write as your final answer all real numbers. How I make that r is I draw an r and then I add a line vertically next to my r. Kind of two vertical lines making that r. What it's actually meaning is all real numbers. That fancy R means all real numbers, which is true. If I'm going from negative infinity to infinity, that is the furthest I can go number wise. If the boxes you fill do not match, one is an infinity symbol and one is a number, your final answer is circling the X or Y with the number box, including the inequality sign between. Let's go ahead and take a look at what I'm talking about here. For number 4, we want to find the domain and range. I'm again going to do just what I did before in my blue color. I'm going to highlight the left and highlight what's on the right. Noted that this time, when I highlighted that left side, it was an arrow. That arrow is going to keep going up and left. I'm not worried about the up, but I'm worried about the left. Because if it's going to keep going left, notice on my x-axis down here what's happening. I'm going from 0 to negative 1, negative 2, negative 3, negative 4. I could keep going on and on forever until negative infinity. How you can draw this infinity symbol is you can turn your paper sideways and draw an 8, or you can put two small circles next to each other. But it must be negative infinity because it's going to the left more towards those negative numbers. We look at the right side. Notice again on the right side, I didn't circle a point, I circled an arrow. So that means it's going to positive infinity. Why it's positive infinity is because this arrow has two directions, which is up and right. And because it's going right here, I notice on my x-axis, I have 1, 2, 3, 4, 5, 6, 7 going all the way till positive infinity. We had a note above that when I have negative infinity less than x being less than infinity, I put in my final answer as all real numbers. Again, how you make that R is you draw a vertical line and then draw an R next to that vertical line. No equal signs for negative infinity or infinity. We talked about that when I flash back to this slide in our second note there. For the range, let's do the range. I'll go ahead and highlight in pink my bottom. Notice it's a point. Remember, because it's the range, I select the y value of that bottom point, which is negative 3. It's a filled point, so put a line underneath before our y here. At the top of my graph, I'm going to circle what I have. I have arrows going up and left and up and right. Good thing is that I'm looking at the top, which is the up portion, and that's going to keep going. If I look at my axis 1, 2, 3, 4, 5, that's getting more positive until infinity, because I could go 6, 7, 8 and keep going on and on forever till infinity. Arrows keep extending beyond your graph on this piece of paper. When I have the note above saying that I don't have matching boxes, one is a number on the left, and on the right I got an infinity. So I have to circle the y or x with the number box to be my final answer and the inequality in between. So my final answer, I'm just going to copy and paste that over here, is negative 3 is less than or equal to y. Sometimes you might see it as y is greater than or equal to negative 3. Notice that both times the alligator that you were taught back in elementary school is still open to the y value. For number 5, we want to find the domain and range again. So let's go ahead and highlight what is on the left of our graph. It's an arrow. It's going left and down here. Arrows on our graphs have 2 dimensions, unless it's a vertical or horizontal arrow. We go ahead and have our domain going until negative infinity. Again, why did I choose negative infinity? Because I'm looking at my x-axis and I see 0, -1, -2, -3, -4. That would keep going on and on forever into more negative numbers. That's why it's going to negative infinity. On the right, again, that arrow's two-dimensional here. It's not vertical or horizontal. So it's going right and down. Well, I'm worried about the right. And when I notice right on my x-axis, I have 0, 1, 2, 3, 4, 5 going on and on forever. I can keep counting until infinity. When I have this, note above what we write, which is going to be all real numbers, because it is going left forever and right forever, covering all real numbers for our x values on that x-axis. For the range, I'm looking at the bottom points or arrows, and I notice down at the bottom, we have arrows. They keep going down till negative infinity because, again, check your y-axis. We're going 0, -1, -2, -3, -4, -5, on and on forever, more negative to negative infinity. At the top of my graph, let's go ahead and bold that point there. It's a point, so I use not an infinity, but a number, specifically the y value here for range, at -1. And I put an equal sign because that point is definitely included on our graph and filled. At this time, because I do not have matching boxes, I don't have negative infinity with infinity, I don't have a number with a number, I have negative infinity with a number. I go ahead and circle the y specifically here with the number box, including the inequality in between. My final answer is y is less than or equal to -1. Or if I were to switch that, -1 is greater than or equal to y. Again, the alligator is opening to -1 both times here. Head back to the first page of your notes, find this continuous domain and range section because we're now going to fill in these 3 problems. Notice that domain and range just have a blank next to them, so we have to put in the notation we've been using. Less than x is less than, leave space before and after like we had those boxes before. And for the range, because it's the y values, less than y is less than. Now let's go ahead and do the same kind of process we did, just taking away those fill in the blank boxes and writing it ourselves. The domain, we're looking left to right. So I'll highlight what's left. That's going before my less than x symbol here. And because it's an arrow going to the left, we go till negative infinity. Then let's go ahead and highlight what's on the right of this graph. At very far right, we have an arrow, which means it will keep going on forever. To the right, which is positive infinity. Remember that when we have two infinities, negative infinity to positive infinity, we have to write our final answer as that fancy R for all real numbers. The bottom of my graph is what I fill in first, and that's going to be this arrow at the bottom. Since it's at the bottom and that arrow is going left and down, it's going to keep going down forever until more negative infinity y values. At the top of my graph, I have an arrow as well, and that's going to keep going up on my y-axis here till positive infinity. Again, negative infinity is less than y is less than infinity is a notation of all real numbers. For our next example, again, we want to go ahead and fill in the less than x being less than and less than y for range being less than. X is for domain, y is for range. We look left to right for domain. Highlighting what's on the left, we have an arrow. It's going left and up. But for our x value's sake, it's going to more negative infinity numbers on the left. Looking at our x values on the right, what's happening to them? They keep extending right until positive infinity. Again, because it's negative infinity less than x being less than infinity, we have all real numbers as our final answer. For our range, I look bottom to top. At the bottom, I have a point in the y value because its range of that point is -2. Put a line underneath your less than sign to make it less than or equal to, since it is a filled in point. At the top of my graph, I have arrows that are going to keep going up and up forever. I have two of them, but they both go up. One goes left and up, one goes right and up. But for range sake, I'm worried about bottom to top, down to up. So since it's going up forever, it's going till positive infinity. At this time, because I do not have the same number with number, negative infinity with infinity, I have to circle the y with the number side as my final answer. You can rewrite it if you so want to, but circling that portion is fine as well. Last example here, we go ahead again and highlight the points on the left and the right. They're points, so I go ahead and write my less than x being less than and filling in the left x value of that point at -2. And looking at the right point, the x value at 4, please make sure you have lines underneath because they are filled points. Range is bottom to top. I'll go ahead and highlight the bottom point, and that is going to be the y value of that point at -6. Make sure you put less than y as less than, and because it's a filled point at -6, the y value there, we go ahead and put a line underneath. At the very top of our graph, the highest point, notice it's different than the left and right point here. Make sure you go and separate these domain and ranges. We have the highest point at 2 comma 4 because it's the range. We need the y value of the highest point, which will be at 4. Put a line underneath your less than symbol to make it less than or equal to, since it's a filled point.